Hey, this is Mr. Janes. In this video, we'll be introducing Unit 2 of Geometry and Statistics at East Hartford High School. Now, Unit 2 starts by looking at probability. In a minute, we'll be working on this worksheet together, but you've probably heard of probability before. Most folks learned about probability in middle school, in 7th and 8th grade, and so to review that, we're going to use this green sheet, right? You may not have this green sheet right now, or maybe laminated under your desk. Either way, we're going to touch base on this and then come back to this worksheet here. Let's jump in. First, what is probability? Well, probability is how likely an event is to happen. It can be written as a percent where it ranges from 0%, impossible, to 100%, certain. So if I told you that there was a 0% chance it was going to rain tomorrow, that means it's impossible that it was going to rain, or at least that's what I thought. 100% chance of rain means it's certain it's going to rain tomorrow, or at least that's what I'm predicting. You may have heard people say there's a 50-50 chance. Well, 50% is right in the middle. That's an even chance that something could happen. As you get lower, maybe a 25 or 10% chance, things are less likely, and an 80 to a 90% chance, things are more likely. Now, probability can also be written as a decimal or as a fraction, where it still ranges from 0 to 1. So instead of 50-50, I could say there's a 1/2 chance of something happening, or 1 out of 2 chance of something happening. That'd mean the same thing. Again, it could be a decimal, a fraction, or a percent. Now, there's two kinds of probability. There's theoretical probability and experimental probability. This says that theoretical probability is found by dividing the number of favorable outcomes by the number of outcomes. It can be written as a fraction, decimal, or percent. Now that's a little confusing, so let's actually talk about what that means. If I have a coin, like this quarter here, it's got heads on one side, and it's got tails on the other. Now if I said I was going to flip this, what are the chances it comes up heads? Now you'd probably say there's a 50% chance, because there's two options, heads and tails, and I'm asking for one of them, heads. That's 1 out of 2, which is a 50% chance. That's the theoretical probability. But the experimental probability says, well, we don't know if the coin is actually a fair coin. Maybe this head sign is heavier, so when you flip it, it'll come down more and you'll get tails more often. So we should flip it a bunch of times just to check. So if I went and flipped it, and let's say I got tails, and I flipped it and I got heads, and I flipped it and I got tails, and I flipped it and I got tails, and I flipped it and I got tails. Well, that's a lot of tails. You might start to think that actually the experimental probability is different than the theoretical probability. We thought in theory it's 50-50, 1 out of 2 chances I get heads, but experimentally we're starting to get more tails. Right? So that's the difference between theoretical, what you think is going to happen based on the options, and experimental, what actually happens after you do the thing, right? You flip the coin. I'm going to jump down to example 2 to show you a little more of what I mean. If I asked you what the probability you flip 2 coins and they both show heads is, then experimentally you would think, well, there's 2 options here, okay? Heads or tails, and if I can flip the first coin and get heads or tails, I can flip the second coin and get heads or tails. So altogether, there's actually 4 options. Heads and heads, tails and tails, tails then heads, or heads then tails. And so if I asked you what's the probability that they both show heads, that's 1, right here, 1 out of 4 total options, 1 out of 4. Which if you pop that in your calculator, 1 divided by 4 is 0.25. That's your decimal. Or to get the percent, you multiply by 100, 25%. Now that's the theoretical probability. But let's say we actually go ahead and flip these 2 coins a bunch of times. So maybe I have this coin, and I grab a second coin right here, and I flip them a whole bunch of times. For example, here I got, call this the first coin. Tails, tails. And so I would go here, find tails, tails. I'd put a 1 there. I flip them again. Okay, this time I got heads, heads. and I put a mark here. And I keep going until I flip enough times, right? Let's say I flip 18 total times. And now, from my data here, there are 5 heads flips out of 18 total flips. So 5 out of 18 is my experimental probability. That's the fraction. As a decimal, I can divide that in my calculator. 5 divided by 18 gives me 0.28. That's the decimal. Or a 28% chance of getting heads, right? So it's pretty close, the experimental 28% and the theoretical 25%. They're pretty close, but they are a little different, right? In this class, in geometry and statistics, we're mostly going to focus on the experimental probability, and you'll see why in just a minute. But I'm going to stop the green sheet here, and I'm actually going to go back to our worksheet and do some work. So make sure you have this worksheet so you can follow along. Let's start here with number 1. The diagram below shows the type of candies in a candy dish. Some are chocolate, some are coconut, some are both, and some are neither. We have a little picture here. We've got the dark ones, right, that are chocolate, the light ones, not chocolate. We've got the C ones that have some coconut in them, and the rest are plain. We're going to create a two-way table and a Venn diagram to show the different types of candies. So using this information up here, let's go ahead and fill in this two-way table. This first box here is the number of cookies that are both chocolate and coconut. So if I look up here, I've got 1, 2, 3 that are chocolate, they're filled in, and they have a C on them, so chocolate and coconut. So that'll be 3. Now, how many don't have chocolate and have coconut? Well, there's just one. It's this one right here. So that'll be a 1 right there. And lastly, what's the total amount that have coconut? Whether it's chocolate or not chocolate, doesn't matter. Total amount, coconut, goes in this box. Well, I could count 1, 2, 3, 4. Or I could add 3 plus 1 together and get that there are 4 total that have coconut. I'd like you to pause the video here before I put up the answers to these. Try this on your own to fill in the rest of this table. Pause the video now. The answers will be coming up in 3, 2, 1. Did you pause? If you didn't, here come the answers. And here are the answers. We've got 6 cookies that are chocolate and no coconut. 1, 2, 3, 4, 5, 6. We've got 2 cookies that are no coconut and no chocolate. 1, 2. And we've got 8 total cookies that are no coconut. 1, 2, 3, 4, 5, 6, 7, 8. Now, I can also have the totals of the chocolate, which are 9. 9 chocolate cookies, 1, 2, 3, 4, 5, 6, 7, 8, 9. Or I could have just added 3 and 6 together to get 9. My no chocolate cookies, there are 3 of them. 1, 2, 3. But I could have added 1 and 2, my coconut, no coconut, to get that 3. And the total is how many total cookies I have. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. But again, I could have added 4 and 8 to get 12. And I could have added 9 and 13 to get 12. In this class, we're mostly going to use two-way tables. And that's how they work, right? In these inside boxes here, you fill in the number of cookies that satisfy both of these conditions, like chocolate and coconut. There's 3 of those. And then on the bottom and sides, you fill in the totals, ending with this number here, which is the total, how many total cookies there are. We occasionally might use a Venn diagram that looks like this. You have one circle, let's label that chocolate. And we have another circle, let's label that coconut. And we can start to label how many cookies fall into each of these circles or where they overlap. For example, how many cookies are in the overlap? In other words, how many cookies are both chocolate and coconut? Well, we can count 1, 2, 3. Or we can look at our table. Coconut and chocolate is 3. So that 3 goes right in the middle. chocolate, and coconut. There's 3 of those cookies. How many are just chocolate? Just chocolate. Well, I can count. 1, 2, 3, 4, 5, 6. Or I could look at my table. 6 are just chocolate, no coconut. That'll go here. Pause the video now and try and fill in the rest of this Venn diagram. There should be a number here. And also, there should be a number on the very outside. Pause the video now. The answers are coming up in 3, 2. Did you pause the video? Here come the answers. 1. And here are the answers. There is 1 cookie that is coconut, but not chocolate. So it lays over there. Here it is. There's the cookie. And here it is in our table. And there are 2 cookies that are outside of this entire diagram. They have no chocolate and they have no coconut. That's these 2 right here. And in our table, that's right here. Now, we're not going to use Venn diagrams very often. We're typically going to use these two-way tables. So if this was a little confusing to you, don't worry. As long as this first table made sense to you, you're going to be okay. Let's actually use a table now to answer some questions. Number 2 says, Miss Sarah surveyed her freshman and sophomore students to determine whether they take a car, bus, or walk to school. The results are below. First, it asks us to complete the two-way table. So we've got this table here, but there's a bunch of blanks in it. It turns out that we can actually fill in a lot of these numbers without actually knowing the survey data. I'll fill in a few for you, and then I'll pause the video and have you fill in the rest. Let's take a look at the students who drive cars to school. It says that there are 10 freshmen that take a car to school. Maybe they get dropped off. We don't know how many sophomores, year 10s, take a car, but we do know the total is 16. Well, if these two things have to add up to a total of 16, then we know that 16 minus 10 leaves us with 6 year 10 students that take that car. Let's do one more. Now if I know that there are 6 year 10 students that take the car, 7 that take the bus, and 5 that walk, can I figure out how many year 10 students there are altogether? I could. I could just add them together. 6 plus 7 plus 5 will give me the total number of year 10 students. 6 plus 7 plus 5 gives me 18. Pause the video here and try and fill in the other 3 missing squares. Pause the video now. The answers are coming up in 3, 2, 1. And here are the answers. How did I do it? Well, to figure out how many year 9 students walked, I knew there were 24 total year 9 students, and so I took 24 and subtracted off the 10 that took the car, the 8 that took the bus, and I was left with 6. To figure out how many total students take the bus, I just added the 8 year 9 students that take the bus and the 7 year 10 students that take the bus and got 15. And then down here, once I knew that there were 6 year 9 students that walked and 5 year 10 students that walked, I added those together to get 11. Now, I could check my work by seeing that there's 16 students that take the car, 15 total students that take the bus, 11 total students that walk, and if I add 16 plus 15 plus 11, I get 42. So that works out that way as well. And if I take the 24 year 9 students and the 18 year 10 students and add them together, I get 42 total students. So that works out too. The whole table works. Let's try and answer some of these questions down below. How many total students did Miss Sarah ask? Well, I could add together all of these numbers on the inside of the table, or I could remember that this number right here, my total, gives me the total number of students in this whole table. So, Miss Sarah asked 42 students. Total students. Now, how many of those students walk to school? let's see. It didn't tell me anything about what year they were, so it must want the total students, right, that walk to school. So walk, total, 11. 11 students. What is the probability that a randomly selected student walked to school? Okay. Now, probability here is how likely an event is to happen. We find probability by taking the number of students who walk to school and dividing it by the total number of students. So walk to school, that was 11. And the total number of students was 42. So 11 out of 42 students walk to school. Now, probability can be written as a fraction. And so technically, I could stop here. But probability can also be written as a decimal. And so if I pop that in my calculator, 11 divided by 42, I get 0.26. And so that's the probability as a decimal. Probability can also be written as a percent. So if I take 0.26 and multiply it by 100, I get 26. So 26% of our students walk to school. D, how many students are in year 10? Let's see. Year 10, that's right here. Year 10, 18 of them. 18 students. What is the probability that a randomly selected student was in year 10? Okay, so there's 18 students in year 10 out of 42 total students. So the probability is 18 out of 42. Again, I could pop that in my calculator and I'll get 0.43. Or I could multiply that by 100 and get 43%. So there's a 43% chance I select a student that is in year 10. All right, now it's time to try a little more on your own. Turn the page over and try number 3. The English and art teacher each reported how many students passed their classes. The results are below. Complete the 2A table. So first they give us this 2A table that's partially filled in, and you can finish filling it in using the same techniques we did on the last page. A quick hint is maybe you should start with this box over here and this box over here. You can use what's already on the table to help you fill those in. Next, they ask for the grand total of students. My hint there is think about the total, right? How many total students right here are in this table. Then it asks you how many students passed English. Let's see, passed and English. It's going to be inside of the table. Looks like it might be this number right here. Okay. For now, cross off C. We're just going to skip that question. And then keep going. How many students failed? Total students failed. How many total students took art? What's the probability that a randomly selected student took art? Remember, we're taking the number of students that took art and dividing it by the grand total of students, right? And so on. How many students failed English? What's the probability that a randomly selected student failed English? I'm going to stop here. And this time, I'm not going to show you the answers. I want you to try this one on your own. And you're going to finish these on your own. When we come in on Monday, you'll be able to use this sheet right here and all of your notes you've taken to try a graded warm-up. Then we'll go over it and move in talking about kind of the high school version of probability. So again, please finish this on your own. Bring this into next class, where we'll do a graded warm-up based on these topics right here. I'll see you Monday.